Hey there, my name is Frank Caron and I'm a technical product manager here at Reach Financial. I'm here today to tell you a little bit more about our Reach 2.0 SageMaker integration. Now this is a super cool part of our stack. During the borrower application process, we use Salesforce flows to orchestrate some of the business logic and Salesforce Einstein Discovery to make a prediction about whether or not that borrower is going to be the right fit for a certain pricing based on their credit. We're going to be replacing that Einstein Discovery call with a call to SageMaker, AWS's vastly more powerful and performant model and prediction tool, which our risk team is already using to create the models that we use with Einstein Discovery today. By introducing SageMaker for a real-time call-out, we'll actually be bringing the two stacks together and seeing a huge increase in performance as well as power and our ability to deliver models that will actually produce even better outcomes for the business. To do this, we've got to introduce a little bit of additional AWS infrastructure. And as you can see in the diagram above, there's a few new blocks in the mix of our Lego kit that we're going to be working with. Let's dive in and take a closer look at some of this stuff. Now we're starting with CloudFormation, which is AWS's tool for building infrastructure from metadata. This is actually very similar to what Salesforce does with metadata, where all of the configurations of the Salesforce platform are stored as human-readable text and configuration as opposed to code. With CloudFormation, we can build a stack and provide configuration variables like the ECR registry you're seeing here, which is a repository where risk can store their models, as well as S3, which is another storage system for some of the testing data that goes along with the models. These configurations come together with a stack to allow us to define infrastructure as code and roll it out safely, including things like being able to roll back if something is broken when we're doing a deployment, as well as spin up multiple instances or multiple environments with the same configuration, so that we can be sure that our testing, staging, and production environments are all the same. As we go through this process, all of the resources or all of the components of our infrastructure, as well as the configuration needed to make them work, are all provisioned for us. And AWS provides us with a great tool to manage that release. So what are those components? Well, let's dig into the CloudFormation structure in a little more detail. You're looking at the CloudFormation Designer, which allows us to map out the different resources and configurations we're going to need to get the job done. The first additional piece of the puzzle is a VPC endpoint service. This serves as the entry point for Salesforce to enter into our private connection. We then route traffic to a network load balancer, which is listening with that listener for traffic coming in from Salesforce. And then we reference from that traffic an application load balancer, which turns that internet traffic into language that SageMaker will ultimately be capable of speaking, HTTP. That HTTP traffic is then routed over through another target and another listener to a Lambda function. This is a bit of application code that we've written and permissioned with 3 different permissions to be able to ultimately manage the input from Salesforce, parse the data, and then make a call to our SageMaker services. You can see here that we're actually referencing some Python code, but this can be any application code that we want to bring to bear, and it's completely up to us how this logic works. It's a lot like writing customizations on Salesforce, except we have control of the underlying servers and can make things a little more powerful at the same time. Now, Lambda has been given permission to call to SageMaker. We have a SageMaker endpoint, which has an endpoint configuration, which allows us to then reference the infrastructure that we want behind a model, which points to that S3 bucket and that ECR registry with the data from our risk team. And of course, that's been permissioned. All of these components work together to give us a private bridge that Salesforce can connect to off the public internet. What's really cool is that all of this configuration is also then stored as just a plain text file that's human readable. That means that we can put it into a code repository, we can manage versions on it, and just like Salesforce, that metadata becomes something we can release safely and test. It can be a little intimidating, but it's actually quite a lot like Salesforce. Now let's get back to our stack. Our resources have been finished, and we now have access to all of that configuration as AWS services that we saw in the diagram. To create the connection between Salesforce and AWS, now that we've finished the AWS work, the first thing we need to do is connect our VPC endpoint service to Salesforce. On the Salesforce side, we're going to set up the Private Connect connection, which requires us to take some information from Salesforce and permission Salesforce for access to our unique instance. This creates a trusted relationship between the two endpoints and ensures that they can communicate with one another. Now, when we do that, we actually are going to use Salesforce to ask for permission to create that connection. And this is a one-time process that involves creating that tight coupling between the two platforms. So we're going to take that service name and edit our developer connection here. And we're going to tell Salesforce that we want to provision the connection now. Salesforce begins that work and allocates the appropriate ports, as well as ask for permission. And we've set up our AWS side to accept permission from Salesforce automatically. So we'll see that Salesforce says we're good to go. And now we just have to wait for AWS to say everything's okay. Now, while we're waiting, we'll set up the other piece of the Salesforce puzzle, which is the named credential. Now, the private connection enables a bridge for traffic to travel across, but we actually need to connect the two endpoints together when we make a call out. To do this, we're going to take the address of our load balancer and input that into our named credential. The named credential takes that endpoint and that private connect connection and uses those two things together to ensure that any callout that goes to that endpoint using that named credential will flow across the private bridge. Now, if we speed up here, we'll see that we've been approved, and now we've created that direct bridge, and we can confirm on the Salesforce side that all is good. Now all we do is make an HTTP request with a payload that our risk team needs for their models directly to the callout, and boom, we've got direct transit between Salesforce and SageMaker, generating a prediction through our infrastructure in less than 100 milliseconds. Huge improvement and a really exciting look into the future of how AWS and Salesforce are going to help take Reach to the next level.